QuantumRock uses machine learning for the research and the development of investment strategies. So why actually does QuantumRock use machine learning? What's the benefit?
Well, machine learning is a very advanced topic of artificial intelligence, and it has a long history of development over many decades, and the whole field is about finding patterns and regularities in the data, and this is why machine learning is a perfect fit to financial problems if used properly. So once again, it's about finding patterns and regularities, and in the machine learning we have a lot of tools and a lot of methods that help us to find these complex patterns. And these patterns can be very non-linear, multidimensional, fuzzy, and this is why it's hard to find those patterns for human. So basically, with the help of machine learning, we can use data to search or to run an advanced search for those patterns. And overnight, for example, we can consider or validate over 1 billion of different patterns. And as a result, we find the patterns that are hard to find for a human. And as I have already mentioned, this can be very complex pattern with many parameters that depend on many variables and many features, and they're also fuzzy. Another kind of goal of machine learning is not only to find those patterns, but also to validate them. In other words, it might be the case that those patterns are present in the data just because of chance. So they are not real, they're just there because of randomness. And with the tools or with the methods of machine learning, we can find those patterns and verify them, in the sense that we can prove that those patterns are real and can be used in the future. So once again, it's about finding patterns regularity that can be used for construction of a trading strategy based on the data only.
So Roman, in the investment world, not everybody is convinced that AI can already be used really for signal generation. What is your view on that?
Yeah, it's a very valid question, because I would say that if you use machine learning as it is out of the box, it will not work, because finance or financial data are very special from machine learning point of view. One of the reasons for that is that markets are believed to be very efficient, and if they are 100% efficient, then we have only random walk in the data, we have only noise in the data. But we believe that on the market we have sometimes so-called inefficiency that we can utilize. And this means that we need to find useful signals in a lot of noise. So we believe that data is not just noise, there is some signals, but signals are very weak. And this is why we need to modify machine learning to our financial purposes. One of the modifications that we use is that we heavily rely on statistics to detect weak signals in a lot of noise, and also to verify the validity of these signals. Another difference between classical problems of machine learning or vanilla machine learning is that they usually generate in machine learning task predictions, and this is not what we are generating. If we use financial data to create a model, what we need to generate is action, or in other words, we need to decide what allocation for what instrument to use. In other words, instead of generating predictions for tomorrow, we generate immediately the proper allocation for different instruments. And this modifies the objective of the machine learning. And the second aspect of our tuning of machine learning for our purposes is that we do not generate prediction explicitly. For example, if you want to decide how much to buy or sell for tomorrow for a particular instrument, or in other words, we want to decide allocation for a particular instrument, we shouldn't necessarily have a prediction for tomorrow. Or in other words, if we have predictions for tomorrow, it's not trivial to decide an optimal allocation. This is why we have modified machine learning in such a way that we can calculate our allocation directly and evaluate those allocations directly. The third difference between vanilla machine learning and what we are doing is that we use time series as input for our models. Instead of using the vectors of fixed lengths with features, we use a time series of prices. And based on that input, we need to decide for the optimal allocation for, let's say, next period of time. And for that, we need to have a proper solution. One of the simplest solutions is to compress those time series into vectors of features, and then try to find a model that operates on those vectors of features. But this is a disadvantage of this approach. It might be the case that features that we formulate in this way are not optimal, and they lose some information about the time series. This is why we use machine learning on two different stages of modeling. On the first stage, we try to find the best way to compress time series into vector of features. And on the second stage, we try to find the best model to combine these features into decision for the next period of time. Another thing that I would like to emphasize is that we put a lot of focus on the automation of the whole process. And the main idea behind that is that we want to have as many strategies as possible that are not really correlated with each other. Because if you have a portfolio of many uncorrelated strategies, the whole portfolio shows a good financial performance. And this is why from our side, we would like to have a system that helps us to generate the strategies as quick as possible, as efficient as possible. And this is what we call artificial intelligence system. This is a system that is able to take data and then find patterns in this data, then validate those patterns and generate a working strategy that is already validated and which has a lot of value in the context of the existing strategies.